Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. No code diagnostic strategies. Now, this is a very broad topic. Anything that's not a code, that would be a no code diagnostics, right? So we're going to try and stick more to the drivability side of things just to keep it a little bit more focused. But having this no code diagnostic strategy, because no codes, I have nothing to start with. Now, we talk a lot about workflow. If you've been to any of these classes, you know we talk a lot about having a good, repeatable workflow all the time. And that starts with, when it comes to at least diagnosing, we're going to start with a pre-scan. We want to make sure we check all the systems for codes, right? We could have a code in another system that's not the engine that could be causing a drivability problem. We could have a code in a system that doesn't have a light on the dash associated with either. So we want to always make sure we're doing that good pre-scan and checking all the systems for codes. But then, of course, in this case, we don't get any codes. Then what do we need to do? Well, we need to go through a diagnosis. Code or not, you still need to diagnose the cause of the problem, right? So that's where we will spend a lot of our time there trying to diagnose. And then after we've decided on what the problem is, we will repair the problem, right? Fix it. Do I need to replace? Maybe it's a bad mass airflow sensor. Maybe I have a vacuum leak somewhere, or fuel pressure issue. Whatever we need to do, we fix the problem. And then we get into the recalibration phase after that. So I need to reset something in the system. Maybe I replaced an oxygen sensor on a Chevy and I need to reset the heater circuit. Maybe I replaced the throttle body and I need to do a throttle body relearn. Any of those things, we don't want to forget that. So we want to make sure we have that recalibration step built into our repeatable workflow. And then, of course, after we're done, maybe we clear the codes, take a road test, and then we want to do that post scan to make sure no codes came back. Now, hopefully, if we have a car that started with no codes in the pre-scan, we don't have any codes left in the post-scan. But hey, things happen, right? Sometimes things get left loose or what have you. Maybe a new problem generates itself. So we always want to make sure we have that post-scan so we can return that car back to the customer in the way, hopefully better than when they brought it in. But to add to that, we have to do some things before we get to this point, don't we? And I think when it comes to no code diagnostics, really the most critical is going to be this first one here in the customer intake process. I want to make sure I'm accurately capturing that customer complaint and seeing what's wrong with it. Because it might not be, hey, my engine light's on. It might be, hey, it struggles getting up a hill, or it makes a rattling noise, or it's a no start or an intermittent start, some other sort of problem. We want to try and narrow it down at least to the neighborhood of what we want to look at, right? So intake the customer and then road test to verify the complaint. If it's a noise, hey, I think I have a bad wheel bearing, or I'm getting that sounds like a helicopter in the back of my car. That could be a wheel bearing too, right? We want to verify the complaint, or maybe it's that drivability problem, right? So I drive it up a hill and I say, oh yeah, the thing's struggling getting up the hill. So then you'd know. And then inspect, put the vehicle up on the lift, inspect it, do that 4-corner check on the vehicle, check the tires, check the wheel bearings and all that. Just to uncover the cause possibly, depending on what it is. And then, of course, uncover other possible issues with the vehicle as well. So when we talk about intaking the customer, this is all about defining the problem. We want to determine the customer's complaint. What kind of problem is it? Is it a drivability problem? Is it a no start? Is it a noise? Is it a drivetrain problem? Is it an electrical problem? Do I press down on my driver's side window and my passenger side window goes up? What kind of problem do I have? Ever since you rotated my tires, my headlight went out. We've heard it all before. So it's always a good idea to have a customer interview worksheet. So here's an example right here. I printed up out of ShopKey, and we'll show you how to get to that a little bit later in the program when we go live on the tool. But always good to have a nice worksheet to work off of. The customer can answer the questions. That way you remember, or whoever's intaking the customer, it might not be you specifically, but anyone who's intaking the customer can, once again, that's that repeatability, right? I can ask the same questions and have the same options for answers. That's repeatable. Once we've done that, well, we want to do a road test. Generally, regardless of anything, we just want to take a road test and make sure the car is not ready to fall apart. And also want to see, are there any noises or what have you? Can we figure it out just by driving the car? And then do that pre-scan, check for the codes. Right? But of course, in this case, since we're dealing with no codes, we have, well, no codes in the vehicle, right? So you can see no systems with codes there in that example. So let's say it is a drivability problem. So the diagnostic strategy is going to depend on what the problem is. If it's a noise, it's going to be one strategy. If it's going to be a drivability problem, it's going to be another strategy. So in this case, like I said, we want to kind of narrow this down to the drivability problem because there's a whole host of options for everything else. And of course, this is not an exhaustive list either, because oftentimes it depends on what the specific problem of the vehicle is. But generally speaking, we'll try and give some driveline guidelines. Sure, why not? Some guidelines as to how we might approach this, how we might attack it, and make it repeatable. So first thing, if a drivability problem and I have no codes, well, let's go right to the TSBs. See if there's a symptom-based technical service bulletin that the manufacturer has already discovered, right? Always a great place to go. Then check SureTrack. If you have a Snap-on scan tool, you should have access to SureTrack there. If you have ShopKey or Mitchell, you also have access to SureTrack there. So that's a good place because that's experience-based information based on what other techs have done and tens of thousands of other technicians. And then also, if it's a drivability problem, it's usually a combustion type problem. It's not burning properly. The engine's not operating properly. So remember your basics. Always remember your 4 parts. We need fuel. We need the proper amount of fuel. We need the proper amount of air. We need the proper amount of spark. And then we need the proper amount of compression. So if any of those is off, we will have a drivability problem. If it's not off by a large amount or a large enough amount, it might not set a code and we might not have that light, right? So we want to make sure we're checking all those things like fuel trims, fuel pump, fuel injectors, ignition, mechanical problems, or we want to check to see if there's a broken valve or something in there. So all of these things you would want to check. And then as you're going through this, you will narrow down where the problem might be. And then say, okay, well, I need to test the coil. And then that'll tell you where to go, right? So if we at least start at the top and work our way down, we can drill into this problem and figure out where it might be. So first off, let's talk TSBs. How many TSBs can there be on a vehicle? There can be hundreds, thousands even, depending on the vehicle, I suppose. But having the information on hand, it's a good place to go. Now, before I even get to the TSBs, though, let's talk about TSBs and SureTrack kind of working together. So we have ShopKey right here. Homepage. This is a 2012 BMW 328i with a 3-liter. And if we look down below, we have these 4 columns of information. This is right on the front page. As soon as we've ID'd the vehicle, this is what comes up. So this is, if you see here, it says based on analysis of 512,723 repairs. We have commonly replaced components, common DTCs, and common symptoms. Now, where do we get these repairs from? Well, there's over 1.3 billion repair orders that we have in our database, and is adding more every single day. And it checks for the vehicle, year, make, model, engine code, down to the commonly replaced components, codes, and symptoms. So in this case, you might even be able to use these to see if there's a common problem with the vehicle related to what you're doing. So it's a 2012 vehicle. It's a 9-year-old car. So in this case, most of the time you're going to find like brakes first thing, right? Pads, rotors, wear sensors. Number 4 here, though, ignition coil. That's pretty high up on the list. That's ignition coil and spark plug. That's higher up than the battery. Usually the battery is pretty high. on the list. Wheel, starter, motor. Oftentimes you'll find wheels in there, brakes, etc., battery, but not usually a coil or a plug that high up on the list. You might see it a little bit further down. Window regulator too, number 9. They must have a ton of problems with the window regulators on these things, because that shouldn't even break the top 10, I wouldn't think, out of 500,000 repairs, right? So coils and plugs. Let's look at the common codes. In this case, we wouldn't have a code, but misfire, 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 all 6 cylinders misfiring. Evap leak on the bottom. I think one or two of those is a misfire too, possibly. Those are the manufacturer codes. And then we have common symptoms. So engine does not start. Could be a drivability problem, could be a battery. Engine runs rough. That definitely sounds like a drivability problem. Number 2 on this vehicle, 13,000 times this showed up, engine runs rough, right? So just by looking at this list, we might be able to see, is there a common thread going across with these vehicles, right? So let's check our TSBs. Now I could just go into the full list of TSBs and filter and figure it out that way, but why not just type my problem into the search box and have it filtered for me? All right, so we put in engine runs rough, and then we have a couple options of that. So maybe the engine light's on, no power, misfire and runs rough. We don't know what component we're looking for, so this could be helpful, but right now I don't know what I'm looking at. So I could use these later, but right now it looks like, might not necessarily help us because we don't know what the problem is. And that says engine misfires or run rough ignition coil is number 1, 12,000, almost 13,000 times. So we see running rough right there. Let's select that. And then we will go into our OneSearch Plus results. So this is what we call our category cards. So these are different cards based on categories of information on the vehicle. Based on whatever's plugged into this search box, it will return whatever information that applies to that, filters out all the rest of the stuff. So if you're familiar with how intelligent diagnostics works, it's very much in the same vein, just based on the search criteria. So there are up to 16 different categories that'll apply depending on what we're searching for. So in this case, engine runs rough, we have 6. Yeah, I can count. So 6 different categories in here. First one is TSBs. Also note, if you use this, it does lay it out kind of in a logical workflow as well. So we always want to check TSBs first. TSBs is always going to be the first card if there are TSBs available. So let's go into technical bulletins, and then it will filter down. Now we have just this selection of bulletins instead of the hundreds of available bulletins. These are just ones that relate to engine runs rough. So we'll go into engine control, and these are going to be duplicated across a couple different categories more than likely too. But let's go to engine control because that's our engine's having a problem. Then we have engine misfire due to failed ignition coils, number 1, and then diagnosis of cold start rough running with misfire faults. Well, we don't have a cold start problem, so that's not the issue with this. I have a drivability problem. So engine misfire due to failed ignition coil. Let's click on that. Come in here and it says, the current plan that they have for misfires can be lengthy to complete, does not provide an effective method to diagnose a faulty secondary ignition component. Sounds like they might have a little bit of work there to do in their misfire plan then, huh? But it says go down, make certain to test drive the vehicle, make sure it's effective, follow the inspection and replacement procedure below. So what happened is early models, they put Bosch coils in there. And I guess they must have had a pretty large failure rate. So they replaced them all with Delphi coils. So if any coils are replaced with Delphi, we don't need to replace it, but we do need to replace all Bosch coils with Delphi coils under these situations. So here's an example of how to tell. There's a Bosch coil, there's a Delphi coil. Delphi's got a lot of that metal around the outside. Looks like it's a little more stout. So this would be how they'd want you to diagnose this problem, and that's right from a bulletin. So if I have a drivability problem and I suspect it's misfiring and I don't have a code, because it won't necessarily set a code. If I don't have a code, I can look and see, well, does it have Bosch coils or Delphi coils? And if that's the case, there we go. Delphi coils, nice picture for me too in the TSB. Good to go. All right, how about SureTrack? We had the TSBs. We already looked at that. Most of the rest of these, other than the OEM testing, is going to be SureTrack experience-based information. So let's see what this can provide to us as well. So this is, once again, it's in Shopkey. It's also available on many of the tools as well. Sometimes you need a code to access it though. But we have real fixes here. Number one real fix. So this is based on those 1.3 billion repair orders, year, make, model, engine. How many times was it a verified fix? 7,895 times replaced engine runs rough, replace ignition coil. Next one, engine runs rough, replace ignition coil and spark plugs. Engine idles rough, replace ignition coil. Runs rough, replace spark plugs. So let's see, ignition, coil, 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 ignition boots, right? So all of these, the top, 1, 2, 3, 4, 5, 6, don't even have a code associated. It's just a rough running. We got a lot of coil problems on this car. And that's over 10,000, 11,000, I would say, maybe even more results just on that coil, just for this problem, right? So that's a good place to go. If you click on the article, you get a complaint cause correction, how the tech figured it out. Next one's top repairs. So you may have seen the top repairs graph on our scan tools. Well, it's also available inside ShopKey as well. And it is based on, once again, those repair orders. It does on a range of from 0 to 200,000 miles. And then it gives occurrences, number of fixes at that mileage. So it looks like we got a pretty good spike at 100,000 miles. Looks like we've got a good failure rate there. A little spike over at maybe 75 or so, and so on. So we can see overall, 12,000 times replace ignition coil was the fix. 7,000 times it was replace the spark plug. So we can see how they kind of match up there. So it looks like maybe half the time they did coils and plugs. The other half of the time they just did coils. That's fine. While you're in there, sometimes it might be a good idea. And then we see the other 4, valve cover, variable valve timing, control solenoid, drive belt, fuel injector. Those are all barely even register on the results. We got 12,000 times plus ignition coil, 7,000 times plus spark plugs. Looks like we're going in the right direction, and I might want to start testing my coil at that point. One more thing though is causes and fixes. This is another way to look at this. So this is taking that graph, that parts graph, that information on the graph, and it filters it down by, well, we can do codes, but in this case, we don't have a code, so we do it by symptoms. We can do either or. So if it's just a general engine runs rough, it connects us to all the parts. If it's idles rough, it connects to a couple, and then runs rough while accelerating, which we said was our problem according to the customer, having trouble going up hills. We go on there, and now we see it only connects to 2. Right, so it leaves all of these out of the equation. So sometimes it's not as obvious what the fix might be. So this helps us drill down a little bit further as to what the problem might be. If I had engine runs rough when accelerating and codes this, this, and this, and it went to one item, that's pretty confident that that's probably at least what I need to look at. Might not be the one I want to replace because I want to do some further testing, but that's where I might want to look. Okay, so that was TSBs. That was SureTrack experience-based information. How about let's check fuel trims for drivability as well? Maybe we think it's an ignition problem. Maybe it could be a fuel problem. Maybe we got led down that path by some other information. On that BMW, sure looks like we might be looking at the coil, but we'll look at that a little bit later. But fuel trims is just another piece of our puzzle, so we can see what's going on. And actually, we might be able to tell if there's an ignition problem looking at this as well. So fuel trim is a window that lets you see what the computer is doing to control fuel delivery and determine how the PCM's adaptive strategy is operating. So we take our 14.7 to 1, our stoichiometric air-fuel ratio. Here's our ideal air-to-fuel ratio. And then the oxygen sensor is going to read the exhaust, because that's the first thing the exhaust gets to, first sensor. If it reads that there's too much oxygen, so a lean condition, if there's too much oxygen in the exhaust, it says, I need positive fuel trim, add fuel to the vehicle. So that's where you get a positive percentage on your fuel trim, a positive number. Then it'll keep adding the fuel. It'll creep it up and creep it up and creep it up. And eventually the oxygen sensor will say, whoa, hold up. Too much fuel now. Let's back off a bit. So once it reads rich, it goes, okay, let's subtract fuel, negative fuel trims coming back, right? So it's this constant dance of adding fuel and taking fuel away. Eventually it gets pretty close. We're only a couple percent on either side of 0, but it will still fluctuate depending on the vehicle's operating conditions, right? So we'll see positive and negative as it goes from rich to lean. So we want to remember our relationship. The oxygen sensor is going to read the oxygen content in the exhaust, feeds the short-term fuel trim, tells the short-term fuel trim, give me positive or negative fuel trim. Over time, if the short-term fuel trim, say, is in a positive number for a long period of time, 5%, 6%, 7%, Then the long-term fuel trim learns from that and goes up as well. So then maybe I get a 2%, 3% positive long-term fuel trim. Then when it's up there and it stabilizes, then the short-term fuel trim goes back to where it was. And then maybe it goes up again to that 3, 4, 5, 6%, which pushes the long-term fuel trim up to another block, right? So it's a learning process and it builds upon each other, right? So oxygen sensor feeds short-term, which feeds long-term. So let's see how this would work on a scan tool. We're going to do a little exercise. We're going to create a vacuum leak on a vehicle. We're going to watch the oxygen sensors and their relationship and how they compare to the fuel trim. Going to repair the vacuum leak and then see what happens then. So here's a complete recording of this test on a 2011 Subaru Forester. Now on this vehicle, the rear oxygen sensors are zirconia type oxygen sensor. So that is roughly 0 to 0.9 millivolts. We'll see in there 450 millivolts will be in the middle, or 0.45. Air fuel ratio sensor is in the front. So that ideally wants to be at 1 air fuel ratio sensor. On Subarus, for some reason, they decide to call things different than what the rest of the industry says. So their short-term fuel trim, they call it air fuel correction. And then their long-term fuel trim, they call air fuel learning. All right, so we have a correction and a learning. So correction is short-term, learning is as it learns long-term. So here we are right at the very beginning of the vacuum leak. So we see it's fairly stable leading up to it on very, very few changes in the signal. Rear's pretty flat. This is at idle, by the way. And then we see we're at like a 3% long-term fuel trim. All right, so as we open it up, we see that the fuel trim goes up. This is the front short-term fuel trim. We see the AF sensors going up slowly as well. So that is a lean condition. AF sensors go up under lean. Rear oxygen sensor, the zirconia sensors under lean go down. All right, so we can see how it builds up. And then as the short term is building up, it also builds up that long term. As we go, it keeps stepping up, stepping up. Now we notice the long term also lags behind the short term, because once again, it's that short term feeding into the long term. So the long term hasn't seen enough negative fuel trims once we reapply that that vacuum hose. We took a vacuum hose off. So you can see it goes lean, 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 lean. We were at maximum positive fuel, short-term fuel trim, maximum positive short-term fuel trim there, 35% for the amount of time that the vacuum leak was open. Maximum lean on the rear O2, and pretty high on the lean of the AF sensor. Right, so we went to 1.12. Right, so pretty high. Then when we plugged it back in, the air fuel ratio sensor tanked, dived way down, because now we're rich. Why are we rich? Because I instantly fixed this vacuum leak. It didn't fix itself over time. We just plugged it back in, plugged the hose back in. So everything just takes a nosedive. So the air fuel sensor says, whoa, I'm just being dumped fuel because I had 35% positive fuel trim. And then it says, whoa, hey, I'm getting dumped too much fuel. So it says fuel trim, we got to come negative. Right, so it actually comes down to like a -4 at the bottom right here, and then slowly it recovers over time. Also, when it goes full rich, rear O2 reacts as well, goes up to the rich side as well. So we can see how they react. Front sensor reads to feed the short term, which feeds the long term. So everything kind of lags a little bit behind each other there. So take notes, look at that long-term fuel trim and the short-term fuel trim. At an idle or short-term, it might also give you a clue. If you're looking at plus or minus 5% on either, you're in good shape. It's doing what it's supposed to be doing. If we get to 6 to 19% plus or minus, we have a problem. It is compensating for maybe a wear item, maybe a small vacuum leak, something of that nature. It's compensating, not a lot, but enough. And then red light, anything over 20%, it's probably going to set a code anyways. Anything over 20%, you have a major problem, and you'll probably notice it in the drivability. And like I said, you'll probably get a light. That rule of thumb from back in the Subaru days was anything, if you see double digits in your fuel trims, that's where you're going to want to start investigating something affecting that fuel trim, because double digits, that's right in the middle of your red light there, or yellow light there. So that's a good place to start. If I see double digits, let's just check. And if we wanted to compare voltages between the sensors, we could see if it's stoichiometric, we have 450 millivolts on our oxygen sensor, no fuel trim because it's working the way it should, and it pulses the injector as programmed. If we see lean, say a 17-to-1, that'll be a low voltage on a zirconia sensor, and a positive short-term or long-term fuel trim gives it a rich command. It says, if it reads lean, it feeds more fuel for rich, adds fuel, increases pulse width. On a rich condition, say 10-to-1, it gives a lean command. It wants to lean out the mixture because it's too rich. You'll see a high voltage on a zirconia, and then short-term and long-term fuel trims will be negative as well, subtracts the fuel. Okay, so as a diagnostic strategy, how do we want to approach this if we see some issues with our fuel trims? So if the fuel trim's too high, once again, that means the ECM is adding fuel, so it's putting too much fuel in, so we want to check for something that's giving us too much air. So air leaks, maybe a vacuum leak. Check the fuel system, make sure it's got enough pressure, enough volume to get in there. We'll talk about volume in a second. If fuel trim is too low, it's pulling negative. That means it's too rich. All right, so ECM is trying to remove fuel. It's too rich. Maybe check combustion. The ignition system's not performing properly. Also check for air leaks. Certain vehicles, especially like turbo vehicles, if I have a leak after my metered air, somewhere in the boot or in the intercooler maybe or something like that, if I have an air leak and I go under boost, that is unmetered air. That is getting out, or it's metered air that's getting out. So it's not getting as much air as it metered, so it's going to run rich. And then check the fuel system once again. Make sure I don't have a high pressure situation, leaky fuel injector, something of that nature, right? So we want to check, is it too high or is it too low? All right, there we go. So fuel pump. So we might want to also check the fuel pump. We can check the fuel pump, see how it's working mechanically by using what we call a current ramp test. So we'll use a low amps probe, place the jaws around a wire anywhere in the circuit. So if we can get to the pump, we put it close to the pump. If we pull a fuse, can put a jumper in there. Same thing with a relay, put a jumper in there. We want it around the feed wire to the pump. And what we're going to see is the commutator segments of that fuel pump. So fuel pump's an electric motor, right? It's got windings, brushes, commutators. Most automotive fuel pumps have 8 commutators in the motor. Some newer ones have 10, but it's pretty easy to figure out how many they have just by looking at the pattern. But what we're going to see is, as that pump is running, we're going to see the brushes and the commutators going, and we can see the amperage flow throughout. So they should be fairly rounded. We want to make sure that they are, there are none missing. There's none high or low. If there was one missing, for example, let's say this one right here was just missing, gone, 0, right? Flat line. That would be one bad commutator. And that could cause an intermittent no start condition. If I have one bad commutator on my fuel pump and it stops on that bad commutator and the brush is making contact or not making contact in that case, so I have a bad commutator with no amperage can flow through that, it won't start because it won't be able to get the amperage. Now, those are the kind of no starts you fix with tapping the bottom of the gas tank, right? You tap the bottom of the gas tank, it vibrates the fuel pump, and then it vibrates to a good commutator. And then amperage can flow, and then it'll turn. And then it stops on a good one, and then it starts, and that stops on a good one, and that starts, and it stops on a bad one again. And now I have a no start again. So those are the ones that get fixed if you pull it off the back of the flatbed or something like that, or you tap the bottom of the gas tank and it fires right up. This would be a really good thing to check. If we count out 8 bumps, since this is an 8 commutator segment motor, that's one time around. So we can take our cursors on our scope, and measure how long it takes to turn. Now, a good rule of thumb is if I get 1 revolution in 10 milliseconds, that's going to be 6,000 RPM, and that is a healthy fuel pump. In this case, we see 1.5 times around, so we see 8 plus another 4. That's 9,000 RPM because that's 6,000 RPM plus half of that's another 9,000 RPM. All right, so we see running about 9,000 RPM. So if we wanted to do the actual math on this, we take those cursors, we take our delta time between cursor 1 and cursor 2, we take our difference. 1 revolution in this case takes 6.95 milliseconds. There's 60,000 milliseconds in a minute. So if I take that 60,000 and divide it by how long it takes to turn one time, our 6.95 milliseconds, we get the RPMs of the pump. So in this case, it is 8,633 RPM. So this thing is working quite well. All right. So that's quick and dirty going through a few of the steps. Let's go live and see about a few other things that we can talk about. I'm going to pull this up here. There we go. Log myself out. Use this for water. There we go. Okay, cool. So I'm going to pull up my good old Beamer that we had in class, and let's go to scanner. And we have the vehicle loaded, and let's do a code scan, right? We want to scan it. We have this BMW with a drivability problem. First thing I want to do is do a pre-scan, scan all the modules. Check that out. And 52 modules, no codes. No codes at all. All right, so there's our problem. We don't have codes, but we still have a drivability issue. So let's go into ShopKey real quick. And I'm going to show you where you can get these drivability intake forms, these customer interview forms. Now, you have to, of course, have a subscription to ShopKey or Mitchell in order to get this. I'm sure there's other ones out there, but in this case, I'll show you how to get the ones that we have, right? All right, so here's my main page, and we can see that over 500,000 repairs there on this 2012. So let's go into, from anywhere, any vehicle inside ShopKey or Mitchell, you can go to the service manual. In the service manual, once it loads, we have a general information. We go in there, we have checklists and a symptom checklist worksheet. So that'll open up in another tab. And then we have different worksheets available. So the one I showed in the program there was a condensed version, all on one page. So let's open that up. We can zoom in, we'll be able to print that out and see what it looks like. But things like starting problems. Is it a starting problem? Is it engine quits or running problem? Poor idling conditions, automatic transmission problems. It's kind of a generalized drivability problem. Odor problems. How often does it happen? Usually occurs morning, afternoon, or anytime. Engine temperature, vehicle speed, all good things that you would want to know to kind of understand what was going on. All right. So that is the condensed sheet. And then there's also a full version that gives you 4 pages worth if you wanted to print out 4 pages worth of this. So this is a little bit different. It's a little more in depth. All right. So we have all of these things. Actually, it seems like it's a lot of the same questions, just laid out a little bit differently. Right. So that's good to have. And then down the bottom, there's individual symptom-based checklists as well. So there's engine drivability and automatic transmission, brake steering and suspension, AC, heater and ventilation, manual transmission and clutch, water leaks, wind noise, etc. So those are all available, like I said, from the service manual in ShopKey or Mitchell, general information and checklists can be right there. So that gives us our walkthrough checklist. Okay, so we checked the T. I'm going a little bit back and forth here, but we have that TSB on that no start for the coils, right? So we might want to check the coils. Let's check the fuel trim on this car too. So I have no codes, right? So from my code scan menu, if I have a Windows-based tool, these are all links to that module. So I can just go directly from here into my engine module. Just have to select my simulator here and go into data. And I'm going to check my oxygen sensor control is where my fuel trims are on this vehicle. And we can see the oxygen sensor voltage, whether or not it's working. And then on BMWs, or at least this model, their short-term fuel trim is called additional mixture adaptation. And then their long-term fuel trim is their multiplicative mixture adaptation. Boy, that's a funny word to say, multiplicative. But yes, so that is their short-term and that is their long-term fuel trims, bank 1, bank 2. So we can see that information in here and see where it's at. Looks like we're at double digits. So that would be a problem, especially if it's positive numbers, which it is. So it looks like that might be a lean condition. But this is also dummy data, so we don't need to listen to that. All right, so let's say I suspect the coil. I'm going to my guided component tests. Easiest way to do this. We're going to engine. And we can go into the ignition tests. And we want to do a primary test in this case to get to my current ramp tests. I want to current ramp the coil. Remember how we current ramp the fuel pump? We can current ramp a fuel injector. We can current ramp a coil. We can see how the coil is operating through there using and checking it mechanically. So if we look down below, it says wrap the jaws around the power feed. And then we would see a nice straight current ramp like this. So this looks like it's shaped like a triangle, how it works. So as the coil is charging, We call that dwell, right? Where it's charging up the primary side of the coil. Should see a nice steady ramp up there. If it goes up sharply and then over, I have a bad coil. I have bad windings in that coil. It's too much resistance it's trying to overcome to add that voltage into the coil. So we would have a high spike in the ramp, and then it might go over. In this case, I know many of them as well at idle, or at least part throttle at idle, low RPM, will also be multi-strike. So it gives you an example of a multi-strike ignition system here as well. So we have our one main spike for when it's initially charging the coil, and then it fires multiple times. Every time it fires to dissipate as much energy out of that coil as it possibly can. So we do have a high resistance at the end of each one of those because it's pushing back against what's already in there. All right, so we would see that on a multi-strike. If I hit view meter, I don't have it hooked up to anything, but we would see it automatically sets the amperage in this case scale where I need it to be, and it sets the sweep time where it needs to be, and it puts a nice little trigger there for me. So if I'm hooked up around that wire, which I can't, but in this case, but I would see that nice pattern there. If I didn't see the nice pattern there, then I would know there's a problem with the coil. Also, if we remember that TSB, if it's a Bosch coil, I know I have a problem and I have to replace it with a Delphi 1 anyways. But we know those Delphi 1s could probably fail as well. So just a few different ways we can attack this. We can test it using whatever equipment that we have. Always good to intake the customer and see what their thoughts are, at least to start on the vehicle, and then work our way through and try to get a logical workflow to get through to figure out where is my problem. Now, we just focused on drivability today, but like I said, I only have a limited amount of time. I could probably go for hours on this. We talk about noises and no starts and all those different things. So hopefully we have picked up a few tips here on getting through a no code diagnosis. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.